Training and deploying large scale AI models can be daunting. Teams often struggle with setting up the right infrastructure, integrating multiple tools, and scaling workloads efficiently, all while making the most of available GPU resources. The AMD Enterprise AI Suite helps solve these challenges by providing a cohesive set of tools for cluster deployment, AI development, orchestration, and high performance model serving, all optimized for AMD Instinct GPUs. Hello everyone, I'm Sanskriti Harmukh, Developer Relations at Vultr, and in today's Tech Talk, we will look at how AMD Enterprise AI Suite works on Vultr Cloud GPU to enable end-to-end AI workflows from training and fine-tuning to inference and production deployment. So, without any further ado, let's get started. AI workloads today are extremely demanding, requiring massive GPU compute resources to train and run large models efficiently. With hundreds of billions of parameters in LLMs and complex deep learning architectures, raw GPU power alone is insufficient. Teams often rely on multiple disconnected tools for model development, deployment, and monitoring, creating fragmented workflows that slow down experimentation and production deployment. Scaling these workloads to multiple users and teams adds further complexity. Managing multi-tenant GPU environments require careful allocation of resources to prevent bottlenecks, ensure fairness, and maintain efficiency. Without intelligent orchestration and workload scheduling, expensive GPUs can sit idle or be underutilized, leading to wasted GPU capacity and higher operational cost. Having highlighted the key challenges, now the next question is how to address them effectively. The AMD Enterprise AI Suite provides a comprehensive solution that unifies the multiple layers required to run large scale AI workloads. At its core, it brings training, inference, and orchestration into a cohesive environment, eliminating the need for teams to juggle scattered tools across different stages of AI workflows. The suite also includes pre built microservices for scalable model serving, optimized for AMD Instinct GPUs, and providing production ready endpoints out of the box. Deployment is simplified with automated Kubernetes cluster setup and management through ClusterForge, significantly reducing the time and effort typically required to configure a full AI environment. On top of this, an integrated job scheduler intelligently allocates GPU resources, monitors utilization, and ensures workloads run smoothly. Now let's look at how the core components integrate to deliver the full AMD Enterprise AI Suite. At the foundation layer, we have AMD's Instinct accelerators. These are purpose built for AI workloads with massive compute capability. But raw GPU power alone isn't enough. We need intelligent orchestration, and that is where Kubernetes comes in as our container orchestration layer. However, setting up the production Kubernetes AI environment traditionally takes weeks or even months. That is exactly where ClusterForge enters the picture. It deploys the entire control plane and compute infrastructure, integrating all the necessary open source tools and getting you operational in hours and not weeks. Once the environment is running, we need a smart resource management. This is handled by two critical components working in tandem. First, Kubernetes AI Workload Orchestrator. It watches your GPU utilization in real time and uses topology aware scheduling to place workloads intelligently. It supports job queues, fair sharing policies, and ensures your expensive GPU resources aren't sitting idle. Second, the AMD Resource Manager, which provides the governance layer. This is your multi tenant control system, setting quotas, managing access across teams and projects, and giving you dashboards to see who's using what, when, and how much. Now let's talk about user facing components. AMD AI Workbench is a low code interface with a comprehensive model catalog and integrated MLOps tools. With this, you can launch fine tuning jobs, run experiments, and track everything without needing deep Kubernetes expertise. Finally, when you are ready to deploy models into production, AMD Inference Microservice takes over. It automatically selects optimal runtime configuration based on your model type, hardware profile, and workload requirements. It is a growing catalog of pre built microservices that makes model serving fast and efficient. All of these layers combine to deliver seamless end-to-end environment for training, managing, and deploying AI at scale. Now that we have seen how the AMD Enterprise AI Suite is structured, let's explore it in action. In this demo, we'll navigate the Resource Manager dashboard to monitor clusters and GPU resources. and then dive into AI Workbench to explore workspaces, datasets, and the AIM catalog. This gives a real sense into how the suite's components work together, from resource governance to model deployment readiness. Before we explore the AMD Resource Manager dashboard, let me briefly show you how the platform environment is set up. We use the Bloom installer, which automates provisioning Kubernetes, GPU drivers, storage, and all the underlying services that enable the AMD Enterprise AI Suite to run on the cluster. I'm already running the installer locally at port 62078. Here you can see the steps that Bloom performs, which involves validating the configuration, checking system resources, installing dependencies, configuring GPUs and storage, and setting up the core cluster services. This prepares a fully functional environment capable of running AI workloads. For detailed instructions and to achieve this result, please refer to the supporting reference guide linked in the description of this tech talk. Once the cluster is up and running, the next step is to secure it with HTTPS. The AMD Enterprise AI Suite requires a valid TLS certificate for accessing the Resource Manager dashboard and the platform's exposed services. I've already generated a wildcard certificate using Certbot. Now, to make the certificate available to the platform, we'll create a Kubernetes TLS secret for the HTTPS gateway. Next, let's verify that the certificate has been successfully registered. Once we confirm that the secret is in place, it's time to restart the HTTPS gateway so it loads the updated certificate. After the rollout completes, the Resource Manager dashboard is now accessible over HTTPS using the configure domain. So let's now navigate to the set subdomain for accessing the AMD Resource Manager UI. Here, Keycloak handles authentication. We sign in using the default credentials. Provide devuser at the rate your domain name as your email and click sign in. Further, enter password as your password when prompted and click sign in again. Upon first login, the system prompts us to reset the password. After setting a new password, hit submit. We have now entered the AMD Resource Manager UI, ready to explore the platform. Starting with the dashboard, it serves as the central command console for the infrastructure powering the AMD Enterprise AI Suite. This is where the platform teams monitor nodes, the available GPU capacity, and defines what each project can access. In our deployment, we currently have one cluster online, one GPU node active and healthy, and 8 AMD Instinct MI325X GPUs available, which is a substantial amount of compute. None of these GPUs are allocated yet, so we are starting with a clean slate. If you want, you can also expand the project view by clicking on a specific project. Since our project currently has no workloads deployed, all usage metrics including jobs, quotas, and GPU consumption are at zero. If there were active workloads, this section would display real-time information such as running jobs, GPU allocation per workload, and historical usage trends. Next, the Clusters tab in the Resource Manager UI provides a high-level overview of all the Kubernetes clusters registered with the AMD Enterprise AI Suite. You can click on a specific active cluster from the list to dive deeper into the compute infrastructure. Here you can inspect node status, GPU allocation, CPU utilization, and memory usage. You can also retrieve further information about the node assigned to the cluster. Next in the line is the projects view. These help you organize and manage your work in the platform. Let's click on our pre-configured demo project. We have already explored the project dashboard. Let's navigate to the project settings. Under quota is where you can define guaranteed amount of resources that can be used by the workloads defined in this project. Projects can also store and access the secrets such as API key or credentials required by your workloads. You can simply create a new secret or assign an existing one. Storage resources like S3 buckets or file shares are also available here. Both secrets and storage are managed at the organizational level and can be assigned to projects as needed. Coming to user access, only platform administrators can create new projects and assign users to them. Regular users can access and run workloads in the projects they are assigned to. Let's understand secrets further. A secret is a piece of sensitive information such as an API key, database credential, or token that workloads in your project need to operate. Secrets can be created at the organization level or be scoped to a specific project. To use it, you can simply reference the secret name and the platform securely injects it in real time. Now let's talk about storage. A storage resource represents a configuration for accessing a data store, for example, an S3 bucket. It includes details like the bucket URL, access key, and references to the secret containing credentials. Storage resource is also created at the organization level and can be assigned to an individual project. Lastly, the Users tab in the Resource Manager shows active users and the assigned roles. AMD Resource Manager and AMD AI Workbench have two different user roles: Platform Administrator and Team Member. The Platform Administrator have access to everything on the platform. They can even elevate a user's role. But the team member has several limitations. They can only submit workloads to, view workloads in, or delete workloads from the projects they are assigned to. The super administrator role also exists, but they are typically reserved for platform engineers who perform maintenance and background tasks. They also have admin rights to keycloak. So that's the resource manager in a nutshell, the operator facing part of the environment. It provides full visibility and control over the system that supports the AMD Enterprise AI Suite. While AMD Resource Manager handles platform operations, AMD AI Workbench is where developers actually build AI applications. And one of the most popular feature here is workspaces, which provides GPU accelerated ready to use development environments. We have four pre-configured workspace types: Jupyter Lab for interactive exploration, notebooks, evaluation, and fine tuning; Visual Studio Code, a fully GPU enabled IDE for Python development, training scripts, and CI/CD workflows; Comfy UI, ideal for stable diffusion and image generation workflows; and ML Flow for experiment tracking and model registry. Each workspace can be deployed with a single click. You can adjust resources before launching or use Quick Deploy for fast startup. We also have dedicated guides on deploying Visual Studio Code and Jupyter Lab on Vultr Cloud GPU using the AMD Enterprise AI Suite, linked in the description of this tech talk for you to refer later. Next is the dataset section. Datasets are collection of data points where each point represents a conversation, with or without model's expected response depending on the use case. The AMD AI Workbench allows you to create and manage datasets for fine-tuning purposes. The platform also includes production-ready inference containers. The AIM catalog offers GPU-optimized models deployable with a single click. Llama, Mistral, Quen here are not raw checkpoints, but optimized inference microservices with model caching, hardware acceleration, and OpenAI compatible APIs. We also have a dedicated documentation and a video walkthrough deploying Quen using AMD Inference microservices available in the description of this tech talk. For custom deployment, the custom model section lets you train fine-tuning models. You can start by selecting a base image, choose a training dataset, and supply a Hugging Face token for authentication. Once trained, your custom models appear in this list. The Deployed Models tab, on the other hand, lists the active models, from where you can monitor the running inference services. Now let's talk about the chat interface. It lets you interact with your deployed models directly from the dashboard. Currently for us, the list is empty because we do not have any models deployed yet. But once you deploy a model, you can send prompts and get real-time responses, adjust generation parameters, test prompt engineering, and debug model behavior. There is also a compare mode, which allows you to send a single prompt to two models side by side. This is extremely useful for evaluating speed versus quality, comparing architectures, or choosing which model to promote to production. The workload section features a batch job or a service running in the cluster defined by the workload and limited by the quota that the workload owner has. It's empty now because we haven't run anything yet, but once job starts, logs and resource metrics appear here. Finally, API keys allow programmatic access to deployed models and other project resources in AMD AI Workbench. API keys can be scoped and time limited. To configure, you can provide a name, set an expiration date, and choose which model deployments it can access. So this was the AMD Enterprise AI Suite environment, which we navigated through the AMD Resource Manager dashboard and AMD AI Workbench. To go deeper and experiment at your own pace, we highly recommend checking out the guides we have created for you to deploy the workspaces and models on Vultr Cloud GPU using the AMD Enterprise AI Suite. To wrap up, in today's Tech Talk, we explored how the AMD Enterprise AI Suite operates on Vultr Cloud GPUs. We navigated the Resource Manager dashboard, examined AI Workbench, and saw how the core components works in a cohesive environment to manage GPU-accelerated AI workloads. If you're ready to try it yourself, then provision an available AMD Instinct GPU plan in our on-demand regions or reserve dedicated capacity in a location that best fits your needs, and deploy workspaces or models on Vultr Cloud GPUs. To ask questions, share feedback, or connect with others leveraging Vultr Cloud GPU for a variety of use cases, join the conversation in the Vultr community forum. Thank you so much for joining us today. We hope this tech talk helped you build scalable, high performance AI workloads on Vultr Cloud GPU.